Hello and welcome to today's Tech Nugget by Coking.com. I'm Evan Hyde, one of the SMEs with our team. Today we're going to be talking about how can you deal with coke deposits. So one of the questions I'm often asked is, can you dissolve coke? Well, the answer is sort of. There's only a handful of chemicals in the world that can truly dissolve coke. The one that I'm thinking of off the top of my head is called aqua regia. It is a kind of an equal parts mixture of hydrochloric acid and nitric acid. Very nasty stuff. It turns out it also dissolves metal. So most of the things that are going to dissolve coke are also going to dissolve metal. So in terms of the process, it's something that really, once you get to the coke stage, nothing can really dissolve it. Now, there are things that can disrupt the formation of coke and allow the smaller coke particles or asphaltene particles or coke that's stabilized in an asphaltene matrix to be dissolved and move down the line. So that's the subject of today's Tech Nugget. We're going to be talking about a couple ways that you can try to manage that. So I'm thinking about two areas in the delayed coker in particular. One of which is in various heat exchangers. We have preheat exchangers in our unit. Almost everybody has them. And those are exchanged with heavy gas oil predominantly, where there is the potential to form coke over very long timescales because the time and temperature is sufficient at those internal heat exchange surfaces where the very mild cracking reactions can actually happen at very long timescales. They don't happen quickly, but if you remember that as a liquid is flowing across a surface, there's what's called the zero slip condition at the surface. That very thin boundary layer at that surface is basically stationary. So if the temperature is high enough for long enough time periods, you can basically make coke. So if you have the ability to isolate your exchangers and you can inject a chemical to break up this coke, which is in its incipient phase where it's hasn't quite formed solid coke yet, maybe it's just small coke particles that are trapped in sort of a sticky asphaltene-like matrix, then you have the potential to dissolve this material away and end up with a clean heat exchanger. Now, the important thing is you can't wait too long, right? Because if you wait too long, then eventually this will turn into hard coke and we're back to the aqua regia stage, right? So the other place where I think about this particular application is in the main fractionator. Now, by and large, the temperatures that the fractionator operates in aren't hot enough to create coke. There are some units in the world that do operate at high enough temperatures to where coke formation can actually and does actually occur in the tower, but these are relatively rare. But one of the things that can happen is we get coke carryover into the tower from the coke drums, right? Hopefully we keep that to a minimum. That's what the anti-foam is there for. But we do know that coke will come into the tower. And again, time and temperature being sufficient, that the small particles of coke can actually come together and form large particles of coke. Now, I, for one, have been involved in turnarounds where we've opened up the fractionator and found many, many feet or many, many meters of coke in the bottom of the tower. Now, hopefully it doesn't happen to you, but there are also conversely times when we've opened up the fractionator and seen that there's basically been almost nothing in there. Big thumbs up, right? But one of the ways that this is accomplished is through the addition of chemicals during the chemical decon process for the tower. And there are a variety of companies that do this. The first one that jumps to my mind, the second is ZymeFlow. They're going to be at the REFCOM events, and you can come and talk to them. I'm sure they'll fill you in on all the great details of how their chemistry works and how it can be used to break up this asphaltene matrix and carry those coke particles out of the tower. The important thing that I'd like to impress upon you, the audience here, is that chemical cleaning and chemical decontamination using specialty chemicals that dissolve asphaltenes saves us tons of time, and time is money in the turnaround, so they are very much worth it in my humble opinion. The days of using steam only to steam out a fractionator are basically gone. And all the turnarounds that I've been involved with in recent years, we have used some sort of chemical decontamination for the main fractionator and various other process vessels to gain entry as quickly as possible. And the Zyme guys, I'm sure would be happy to tell you about when they got entry into a tower in just 48 hours, which is pretty impressive. So this has been your Tech Nugget, where we've shared a little bit about how you dissolve Coke, hopefully not with aqua regia, but with asphaltene dissolving agents to get the small Coke particles out of the system and get you back up and running as quickly as possible. So this has been your Tech Nugget. If you'd like to learn more, please visit us at coking.com, the home on the internet for the best information about all things delayed coking, or you could attend one of our training classes at the RefCom events, where we talk about lessons learned from around the world and new technologies such as what we shared with you today. So we're available on various social media outlets, LinkedIn, Facebook, YouTube, etc. And I hope you enjoyed the video. Thanks.